recording, something along those lines. Let me go ahead and sure I have Okay, I slacked out the stream. We're gonna get started in just a second. Make sure you have the latest changes from the GitLab repo pulled down. I added week 19's activities. And make sure you have the Babel CLI installed globally with NPM. We don't need it right away, so if something goes wrong, we can help you later, but npm i-g babel-cli, just like I have in the Slack channel. Alright, let's go ahead and get started. So, real quick, just since I know how my class feels, but I'm interested in Tuesday, Thursday, Fist of 5, how was Mongo for everyone? Especially compared to MySQL.
I still go to SQL.
You still go to SQL over Mongo? Why?
For me, it's more logical.
Okay.
It's just like a more logical kind of way to do things. Like it's more.
Okay.
If I want to do something, I can program it to do something specific.
Okay. So you like the structure involved with it? I don't disagree with you. I honestly think MySQL and SQL-like relational databases are more valuable in production for most cases. Mongo has its uses, but there's dangers in how easy it is to use. But yeah, you know, there's definitely dangers in how easy it is to use. It's kind of one of those tools where it's so easy and so convenient sometimes that people use it, and that ends up turning into abuse. They don't figure out exactly how it's working. They don't figure out all the intricacies of it, and problems happen. And we ran into that problem at my last job. We used Mongo for everything, and honestly, I learned to not really like it after that. Sure, it's great spinning up a new project, but once you get into maintaining serious data, I mean, we had millions of records we had to go through, and you have no relationships or anything. It makes it very hard. But overall, I think it is easier to learn and a little bit easier to like work with because, you know, it's very similar to the JavaScript we've been doing and stuff like that. So I just wanted to get a feel for how people were doing. Not that it matters. This week, we're going to transition into React. But today, we're not going to do any React. Just to, yeah, kind of dangle the carrot there. We're actually going to be going over all the ES6 syntax that we're going to need in React and like kind of how to set up Babel and make that work properly because we're going to need Babel with React. I'll explain that a little bit later. So I know Tuesday, Thursday, Daniel has mentioned let and const. We're going to solidify those things today. I've shown my class arrow functions too. We're going to solidify those things today. I've shown my class, and I think I've shown Tuesday, Thursday, string interpolation and template literals, where you can use the backticks and just kind of put stuff into a string. We're going to go over that kind of stuff today. And a couple other really cool features. It's really just like the new features that exist in JavaScript that, to be frank, we should have just been teaching you the entire time. But you know what? We're going to waste the whole day going over them now instead. So, yeah. So there's a couple other things, too, that are good to cover, like using Babel, imports and exports and stuff like that, that are the foundations for starting with React, because without them, we can't do anything. So there is a reason to have a part of our class dedicated to like learning the tooling.
So React is only ES6?
Not necessarily. You don't need to, but it'd be significantly more difficult for you if you didn't use the ES6 features. And I think the biggest reason why we want you to know this is it's just pretty standard across the board that people are using ES6 now. No. The ES6 features. They're not using old school JavaScript. So do you need to? No, but it's kind of frowned upon because old school JavaScript is just frowned upon. So that's a good question. React uses a lot of the ES6 features, but it doesn't necessarily require that you do it. So before we get started, is there anything that I can clear up about anything we've covered in class so far? Anyone have any questions? Anything like that? We're almost done. We're really close. We have 3 weeks of React, a week of like data structures, and then you're on your final projects. So, you know, it doesn't feel that soon because we have like 2 weeks off for Christmas, New Year, holiday kind of section, which will be a nice break before you go into that last leg of the class. But after January, we're done. January 28th, Monday, January 28th, the last day for my class. 29th is last day for Tuesday, Thursday, and then we have our presentations probably sometime later that week, and we're out of here. We'll never see each other again. I'm just kidding. I'm just kidding. Yeah. All right. Let's get started. So this one, if you look at the activities, there's a lot of activities. Today we're doing all the 100 level activities. So we're going to start with activity 101. It's a warm-up, actually, so I want everyone to do it as partners. You're going to review scope and functional scope. So go through with your partners, look at these files, try to comment out what you think the values are without running the file. Don't run the file yet. Try to comment the whole thing, say this is what I think it's going to be, this is what's going to print the console and all that. And then when you're done with that, you can run the file and try to confirm and see if you can fill in those misconceptions. But we're just going to spend like a couple minutes going over activity 101 just to get warmed up. So this is your activity right here. So you got to comment this file out and you're not going to run it. It is in GitLab under week 19, activity 101.
At the bottom.
Oops. Okay, so I didn't give you a lot of time, but we're using this as warm-up, so let's go over this together. This first line here, what's it going to output? Anyone?
Line 1, tiny rig.
What?
Line 1, and then tiny rig after.
This is going to input line 1 and then
Yes, line 1.
it's actually going to output undefined.
Okay. Because you called it including one.
Yep. Because name is undefined. So you're just gonna get, we'll get line 1 undefined, I'm pretty sure, but the name is undefined here. So like the line 1 and all that we don't care about necessarily, but right here, with this string that's gonna log, that's what we're caring about. So this one's gonna actually be undefined, which is peculiar, but we'll go over that in a bit. And the reason why is name here hasn't been set to anything yet. It's been hoisted, so it exists as a variable, but it doesn't have a value. So here's our next function, tinyeyes, right? When we run tinyeyes the first time down here, what is this output going to be? This one will be rake. Now, what about my name? When we log my name, what is that going to be? Undefined. Why?
Because my name is defined right after that.
Exactly. It's actually defined with a value right under there. So this is where we get tiny rig. And then right here we have tiny rig, right? So now at this point, name is going to be no, this one's going to be tiny Rick at this point because it's been returned right here, right? So it's already been initialized, but it is now tiny Rick. But this, my name, what is my name going to be? This one's actually going to cause an error because it's hoisted, but it's not even used in the scope. It's used in a totally different scope, right? So this one's hoisted and used in the scope because we have a var declarations right here, but this my name isn't even declared in the same scope. It just is there. You're trying to use it. It doesn't actually exist, so it's a problem. Now this one starts to get a little bit more tricky. What is I going to be? This one's going to be undefined. Technically, this for loop starts in the same scope. So I right here is defined, but hasn't been set yet. So it's undefined. This one is even even more tricky. What is this going to equal? Anyone have any idea?
0 through 4.
0 through 4? It's actually going to equal 5 times. So, let me explain. We're going through the for loop. We're setting I equal to, it starts at 0, right? So, it starts at 0. We start a set timeout that's just waiting. And then it goes through, it sets it to 1, starts a set timeout. 2, starts a set timeout. 3, so on and so forth. It gets to 5, it breaks the loop, but I equals 5 at that point. And these set timeouts have not fired yet. So now I is printing 5 times. So this is a good example of asynchronous programming and the problems you can run into. You can't just call asynchronous code inside of a for loop. You're going to get really weird results that you won't expect, and debugging that is going to be an absolute nightmare. No one here would have expected that, right? And it's something that even more advanced programmers forget too, and then all of a sudden they get weird output and like, oh, crap. This happens a lot. And right here, we're going to get 5 again. Because I has reached the end of the loop, it broke, and the only way for it to reach the end of the loop is to equal 5 so that we can say, oh, I is no longer less than 5, right? So it's going to be 5 at this point. So this is going to be 5 times. Any questions on any of that stuff? We can go ahead and run it.
It actually prints 23 before the set timeout.
What?
The line 23 fires before the set timeout
Oh,
fires.
yeah, that's probably the case too, because it's at 100 milliseconds is a long time. in execution. So it will print the 5 times eventually, but it'll be sometime randomly after probably the rest of the application is executed. So if we run this var example, we get this explosion, which is from this bad boy. Because, like I said, there's no var even defining my name anywhere in the same scope. So because of that, if you go ahead and get rid of it, we can see the relative order of how these things print. So undefined right here. And then we have Rick, undefined, tiny Rick, tiny Rick, tiny Rick again. And then right here, this is undefined. And then we have our 5. And then we have some more 5s. Boom, boom, boom. Any questions on that? So this right here is why var is a bad thing. Because, you know, like, look at the distinction. This one's fine, but this one explodes and causes a problem. This my name. And you kind of don't think it should do that, right? Because this one's undefined, and the only reason it's undefined, it doesn't explode, is because it eventually is initialized sometime in the same scope. So this my name is fine because right under that it's initialized, so it's being hoisted up as an undefined value because it's being initialized here. And these problems are bad. You know, they cause a lot of issue because you're like, why is this randomly undefined? It's pretty easy actually to cause these problems. You know, it really is. So we don't do that anymore. We use something called let and const instead, because let and const, they don't let this stuff happen. So, for example, I'm not going to go over the... Well, yeah, I'll go over this one too, but we're about to jump into it. Using let and const, for instance, this one right here, this name, is now going to throw a reference error and actually blow up and stop the application because it's defined with a const. And const and let, unlike var, do not hoist. You cannot use the variable until after it has been declared with a let or a const, or it's been initialized. You cannot use it before, like with var, which magically lets you just kind of use it. So this would actually blow up, which is what we'd want. You know, we want to know that we shouldn't be using this yet. It's a bad practice. Same here. This my name that was once undefined with var now blows up because it's not defined until right here when we call const to my name. I'll go over the distinction of let and const and all that really quick, but in terms of scoping, this is the difference between them and var, and this is probably the most important difference. So right here it blows up. That's a problem. Right here, this I, log I, that was undefined now blows up because we're defining it with let instead of var. Also, notice that we get our proper output. 0, 1, 2, 3, and 4. That is because let, having block scoping, right here means with the var, we're defining it once, but we're having like that shadow variable effect, right? Where it defines it once and just overrides the old one. But in this case, with let, it's actually saying at the end of this for loop, the end of the block, the let is destroyed and we create a new one. So because of that, every time we go through this loop, we have a new version of I, as opposed to the same one that's being shared across every iteration of the loop. So when we log I right here, we're actually getting the value we expect. So that's another reason to use let and const and not to use var. And then right here, this one's going to explode again because we're outside the for loop. And because we use the let, it's not being hoisted up into the main scope and it just explodes. So yeah, we have a lot more errors in this code. And you may think, well, is the code more buggy? No, the code's not more buggy, and as a matter of fact, we're being helped a little bit because those bugs are being pointed out to us in a very extreme fashion, right? The application's like, you're literally being an idiot, please stop. So there's nothing you can do about it, whereas var, it's like, well, this is pretty dumb, but you know what, go ahead. And that's kind of a dangerous thing. So, the distinction there is real, and from now on, is it super important that you understand that at a really fine-grained level? Not always. Should you? Yeah, because you're probably going to be asked this in an interview. I'll tell you, this is going to be a big interview question right here, var versus let and const and stuff. So understanding the differences in scope and all that are really important, and we'll try to get into it, and I'll try to clear up any misconceptions, or if anyone needs a little bit more time just solidifying it, it's important to know. So feel free to ask questions. But we're about to go into another example, so I'm just going to let the TA slack this one out. They'll slack out the commented version and this let and const example, and then we'll jump into the next example together, and we'll go over let and const a little bit more. So here is our first example with let and const. Okay, so yeah, there are major scoping differences between let, const, and var. Let and const share the same rules, and var does whatever var decides to do. But there's also a distinction between let and const, and that is const is a constant, which means once you assign something to a const, you cannot change it. With some caveats, of course, but you can't change the value that it's actually holding. So for instance, if we create a const, we call it answer, and we set it equal to 42, you can never change const to something else, so we answer to something else, so we can't run this code right here and reassign it to another number. I'm going to just comment all this stuff out, and I'll show you what happens before we see the rest of the code. So right in here, I'll just do node let const intro. Whoops, that is not node. Right here, you can see when we try to reassign answer, it's like, hey, don't do that. That's stupid, right? So, const is really valuable. You may say, hey, why would I want to do that? Shouldn't I have the freedom to be able to reassign stuff whenever I want? And you can by using a different keyword. The reason why you might want to use const is, what if this number 42 for answer is extremely important for some algorithm you have in your application, and if you change this to 41, it's going to be off by, you know, some precision, right? Or it's just going to be completely incorrect. So you need it to be 42, but you don't want to just embed 42 in your application, because then no one knows what the hell 42 is. So say this is like, you know, max width of something on the screen or whatever, right? And if you change it to 41, things wrap weird or they expand weird. I don't know. If you just have 42 embedded in your application somewhere, people are like, why 42? Why do I care about this 42? Is it important? I have no idea. So instead of doing that, you give it a nice name. You tell the user, the consumer of that variable, what it is, so when they're reading your code 6 months later, they don't curse you. You're not allowing them to change it. You're telling the consumer that variable that this is important. You shouldn't change it. And we're actually enforcing that in the language and saying you can't change it. The only way you can change it is to stop your code and physically change it, and you might want to think about that first, because there's probably a reason it's set to a const, right? So there's a lot of value in const, and best practice, you should use const everywhere you possibly can, because you do not want people changing things that they shouldn't be changing. It causes problems. I'll explain that more a little bit later. And here's a good example of using const where you can change the data in the thing that it's holding, but you can't change the thing it's holding itself. So, very slight distinction. The distinction here is known as a value type versus a reference type, getting into more programming concepts. With a primitive, like a number or a string or a Boolean, and like I think even a date, the value you put in there is all there is. It's just value, right? 42 or Carson or true, right? That's all there is to it. There's nothing else. You can't call special functions on them or anything like that. They're there. But like an array, it's a thing, an array, but array holds stuff inside of it, right? So there's more to the array. And when you assign an array to a variable, you're not actually putting the entire array in that variable. You're putting something called a reference to the array. So you're saying, this is where my array exists. This is like to tell me how to get to my array. But if I want to change the array and what's in the array, I still can. And I just need to use this variable to get to the array. And then I can do what I want with the array, right? But you're not actually holding all of the data in the array in that same variable as well. If you were, this wouldn't work. So we can still pop values from the array. We can still push values to the array. But if we try to reassign the array that's assigned to const, we're going to get our favorite explosion again, because you are not supposed to do that. Again, look at the distinction. I can pop from the array, and you can see what it printed out is it will be slightly different in that before and after. See, it's missing the endangered sea turtles. But I can go in here and I can do pets.push hello mom. And I can go ahead and run this. And look, hello mom is in there. I've changed the contents in the array, but I've not changed the array itself. And that is a very, very important distinction. Now that's one that's a little harder to grasp conceptually. Yeah, question?
So if you could practice for the majority of the time to set your arrays to constant?
There's almost never reason not to.
Okay.
So yes. Yeah, Chris?
Oh, no, go ahead.
Yeah.
I was going to ask after you're done answering.
Yeah, there's almost never reason not to set objects in arrays and things like that, because objects follow similar rules. There's almost never reason not to set them to const. There are some reasons, but it's rare, and there's actually practices to move around that too, which we'll go over later in today's lesson. So yeah, that's a great question. Always set them to const. I'm going to tell you right now, just always set them to const.
My question was, there's reference types and what's the other type?
Value types.
Value types.
So your primitives are value types. They are stored as a value in a variable, but your reference types, they're stored as like almost, you can think of the address
Yeah.
to the contents in the value, the variable, right? So
The memory address, right?
yeah, it's a memory address. So you can imagine max width might be your phone number, right? But pets might be literally the address to your house, and to get to you or to get into your house, you have to take that address and then go find it, right? And so we can change what's in your house, but we can't move your house. You know, we can't just pick up the house and move it or dump another house on top of it. We could, but it'd be really bad. In this case, JavaScript's saying, no, you can't do that. So what is that analogy good or not? I have no idea. But time will tell, I suppose. Anyway, let's look at let now. Let's a little easier to understand. Oops. Because it's similar to var. It just has better scoping. Not insane scoping. So with let, works similar in terms of scoping to const. The only difference is you can reassign, right? So if you have a primitive type 10 and you need to add something to it, for instance, like a const, if this was a const, not only could we not reassign it completely, but we couldn't even do time plus equals 1. We couldn't do time equals time plus 100, right? So you can't even multiply or add or do anything because, again, you're changing the value underneath and you're reassigning it when you do those things. So if you need to like do math and you want to keep it in a variable or you want to just reassign it all together, you can, but you need to use let. So right here, it should console log fine. It console logs 12. Way down there, right? So when you need to reassign something, you go ahead and use let. When you want to make sure that it's not changed and something stupid isn't done, you use const. So again, back to the question, arrays and objects should pretty much always be const, and your primitives can mostly be const, but every now and then you'll need to reassign them. Say you have a boolean, a true or false, and you might have to switch it from true to false or vice versa. It's a good opportunity for a let, right? But really what you should strive to is making as much of your application const as possible, because there's less room for error with that. There's just this implicit safety that comes with using const. So any questions on this little example right here? So let's look at how scoping now changes, and we can even compare var to their const versions. So in the var version, for instance, because we have this, we have these shadow variables, right? So we can go ahead and do var x equals 1. We can do var x equals 2 and completely like overwrite it, console log it. But out here, outside of the child scope in this if block, x is still going to equal 2 because we completely overrode it with this shadow variable. That's what var lets you do. It overrides these scoping rules sometimes, which is really dumb. And then right here, in this second test, this is that hoisting issue, right? So we can log a right here because it's defined later in the same scope, and it's fine. It's just like, yeah, that's undefined. That's okay. And then right here, it's equals 2. So if we console logged it again, it equaled 2. Right here in the const example, the first one, we have x equals 1. And let me scroll down a bit. We have x equals 1. Inside the function scope, we set it to 2. Which we can do, that's cool, and really quick, that's cool, and you log it again, it equals 2, but then when you come back out of that child scope, it's back to 1, because we're not overriding with those shadow values anymore, and this is more what we want. We don't want to accidentally override a value inside of a child scope and cause it to be changed everywhere in the application. That causes bugs, and they're hard to find. In this case right here, it's going to go back to its original value, so unless you intended for it to change, which if you did, you would write this differently, right? You would write it you'd have to write it like this, and then you go, oh, well, that can't be a constant anymore. I'd have to write it like so, right, if you actually meant to change it. But in this case, we're saying, oh, we don't mean to change it, so it's fine. The alternative on the second test is we can't hoist, so this is actually going to throw an error in log test 2, or let test 2, const test 2. Won't even work. It'll just explode. Adam, you had a question?
With that example of A, whatever, if we declare first, then we log, and then we find, I'm gonna see the value in the log.
For right here, the var one or the const one?
This one. So if you here, you just, do this.
If I did that,
Yeah.
and then assigned it down here,
Yes.
no, you'd still see undefined here.
Okay.
But this would also work with like a let, because it's just undefined. So even the let would say, hey, this is undefined. The thing with var that's tricky is it says this is undefined when the reality is it hasn't even been used or instantiated or anything, and that's what's dangerous. This one actually says, dude, this thing doesn't even exist yet. What are you doing, you psycho? And it blows up.
What's the hosting?
Hoisting is that particular issue where right here where const b is actually defined, this is the first place you can use it because it's been defined here. In this one, it's defined later in the same scope, but it's actually used before its definition, and for some reason JavaScript's like, that's okay. Right? So that's what hoisting is. There's a time where hoisting is valuable, and that is if I define var test2 here, I could call var test2 there, and it'd be fine. So we've hoisted the function, and that's okay, but that's totally different. That's because however you align the functions, you may want to define them below them. I don't personally recommend doing that. I think if you're going to use var test2 inside of var test1, var test2 should be defined before it, but that's honestly kind of a preference. Anyway, in terms of const, though, in this var, so if we change these to let, like even if I have this as let, I'm going to get the same problem as the const where this will blow up because they have better scoping rules. Any questions? So this is activity 102 that has these rules kind of defined in them, so I would use them in the next activity. So what we're going to do is we're going to go to activity 103, and we're pretty much going to take that warm-up, and we're going to convert it to let and const. So we already sent you that solution. Don't look at it. Try to do it yourself. And you want to see kind of like the differences between that code and the code I showed you with var from that first activity as well. So activity 103, do it with your partners. It's cool. Spend a few minutes kind of converting that.
Right, right. Then I could refund the name.
So it isn't tiny Nick that did right? It's still, at the end of the day, it's still but why did the two console log right there?
Whatever it did, put your name there and there. Well, it's because I had that there. I put this here. And then ran it again. After it. Go. Go to that.
In that case, if you're doing that, like, you can just completely define it somewhere.
I see. Because you have that option. Yeah.
And then you can go in there and change
And change it somewhere else.
yeah. So you can do it. Line one, and we get a line two. And then things get some lines.
Right.
Because one, line one, it's not prime.
All right, let's go ahead and take a look at this.
Right.
So let's run this unsolved version. See what we get.
Big time.
So what we end up with is Tiny Rick console logging right here. Boop. And a bunch of fives, which isn't probably what we expect from much. But if we change it, and we go ahead and run the solved version, we get Tiny Rick again, but we get the 0, 1, 2, 3, and 4. So the big difference is this let block right here allows us to actually print the variable we want inside the set timeout, where var won't because of the hoisting issue and the overriding issue, the shadow override. And in this function right here, I really don't understand why they set this to Nick. I don't know. Maybe it's just to confuse you. Because the reality is this one's not that much different.
They tricked us because they wanted us to set it to a constant.
Yeah.
And then it blows up when you rename equals tiny eyes, right?
Yeah, it definitely can't be a constant, right? So it has to be let so you can reassign it. You can set it to blank, you can set it to Nick, it doesn't much matter. But it needs to be let, because if you set it to a const, you're going to get an error, right? But this one, totally, can be a const, because it's not going to be reassigned. And so this is a good example of like, hey, why would I want a const as a primitive versus a let? This one needs to be reassigned. And now, what you could just do is that, and void name altogether, which is, I think, still preferred. And then you don't got to worry about the let at all. There's no reason to have a let there, right? So sometimes, too, with your linters, as they get really sophisticated, we'll even say, like, you don't need that let. Like, literally, this is only assigned to once. Why would you do that? So it's easy to switch that to just a const. So this is probably the most preferred version of this little function. Set of functions, I suppose. Any questions on these? Did anyone run into any issues that they still don't quite understand or want some clarification on?
Is that set timeout, does it actually wait the 100 milliseconds before printing at this point, or?
Yeah, well, yeah, but it never actually waits totally 100 milliseconds. It's as close as it can get, and there's reasons for that because of how the event loop processes events. You can't guarantee it'll actually be 100 milliseconds, but yeah, every sort of 100 milliseconds, one of these will print, right?
But because it's a let, like you were saying, it gets destroyed, and then the next one fires afterwards. Like it waits
Yeah,
for that
so-
destruction.
No, it doesn't wait for the destruction at all. What happens is, instead of having the var where you'll have literally one variable, you can imagine there's one variable that just gets overwritten. This one will actually create 5 variables. Every time it goes through that for loop, it creates a new variable that happens to have the same name, but because it's in its own scope, because it's in that for loop, it's its own variable. Just like you could do something like, if true, you could do something like this, which would be similar. Or actually even better. It kind of unwraps to a set timeout function like this, const I equals 0, and then console.log I. Yeah, so this is what it's like unwrapping to, basically, when it's running. So we have const I in every version of these set timeouts, or in this case, it's just going to be I, effectively, right? Because it's in its own block here. Even though they share the same name, they look like they're the same, they're no longer are because they have better scoping rules. Cool, so now what we're going to do is go to activity 104 and work with partners to figure out what the bugs are with let and const. So it's some buggy code. You need to debug it in the browser. So there's actually an HTML file you can open up in your browser and try to use the debugger if you can. That's ideal. Otherwise, you can fix it anyway if you want to set console logs or whatever, or just try to see where it blows up, you can. But if you set a debugger, or use a debugger, it's going to make it very easy. And we'll go through using the debugger when I go over the solution. So this is activity 104.
Well, yeah, I think, yeah. Yeah. It's referring to this guy here.
Okay, let's go over this one together. So, if you ran this HTML and you clicked on the buttons, you'll realize pretty dang quick that there is a problem. And that is, for every button you click, they're telling us about this Tamer dude, right? So this button, okay, it's Tamer. How many tacos did CJ eat? Oh, Tamer ate 6 tacos. Well, that's nice. I want to know about CJ. What about Christian? Well, Tamer ate 6 tacos. So fantastic. It's not really what I wanted to know. That is a big problem. That's obviously not how we want this to work, right? And it's because of var being the pain in the ass it is. You guys might have actually run into this issue, unbeknownst to you, several times in your homework by now, and taken forever to figure it out or whatever. Like, it's an easy thing to run into. So why don't we run through the code? So what I did, if you're not familiar with debugging from the console, or from the browser, is you can go ahead and open up the DevTools in Chrome, and then you can go to the sources, and you should see the page, and you can find the JS file that's being referenced by the HTML file, so tacos.js, right? So if you click on these lines, is there anyone who isn't familiar with this, who wants me to go in depth on how to use this debugger? Yeah, don't worry about it. I absolutely will. It's not the easiest tool to use. So if you click on these line numbers, you'll be able to set up what's called a breakpoint. And these breakpoints allow the debugger to stop when that code is being called. And I'll show you that in a moment. So this code, if we look at it, this global code right here is going to be executed as soon as the file's loaded into the browser, right? So we know that when the JavaScript file is loaded by the HTML, it just runs the code. And if there's not a function being called or something, and the code isn't in a function, it's just going to run it. So we're going to be creating all this stuff from the get-go. So if we go in and reload the page, you'll see there's nothing on the page yet. And this breakpoint did what, it caught the code at that point, right? It broke the code. It stopped it for you. So you can look at what's going on in memory, and you can kind of like say, oh, you know, what's happening in my application. So right now there's not a whole lot to look at. Here's your breakpoints right here, so you can manually disable or enable them if you want. It even tells you the scope you're in. You're in the global scope, and here's all the information set in the global scope. So this is kind of nice too if you want to see what exists in that global scope, and we could find classmates in there, actually in that list right here. Boom, classmates. Here's that array. It exists in the global scope, right? And then there's something called the call stack, which we'll go into in a little bit. But I know I'm going to need a few more breakpoints, so I'm going to just set one in this button add event listener, right? Because this isn't going to fire until we click a button, correct? So the breakpoint won't get caught until that happens. So I want that there just so when I click a button, I can see why this is a problem. So if you hit F11, and on Mac, I think it's like Command Shift semicolon or something weird, but if you're on a normal OS, then you can use F11 and you can move on through, right? So we know that Classmates has got a length of 3. I is going to start at 0. So now I is 0, Classmates length 3. So we're going to get the first classmate out, which is Christian. We're going to create a new button, and you can even look over the button and see what it looks like. You can see the classmate's Christian, all that fun stuff. And we can see that it's going to build the inner HTML on that button. How many tacos did Christian eat? And that's why the buttons look like they're coming in okay, right? How many did Christian eat? It adds the event listener to the button. You notice when I hit F11, it just skips all that because that's a function it's calling, and the event listener hasn't been triggered yet. And then this wrapper that we pulled out, this div, we're going to go ahead and append the child button. Boom. There you go. The button appears on the screen. So for the next classmate, we'll pull out CJ. It creates the inner HTML. We got CJ. I'm just F11ing through all this. We're good. Now it's going to create this guy Tamer that we always hear about. So right now the for loop is done executing. I go into this weird code. I don't need this weird code anymore. So if you hit F8, it's continue. So it just go, right? And now what we're doing is we're waiting for something to happen. In this case, we're waiting for these buttons to be clicked. So I can go ahead and uncheck that right there. I don't need that breakpoint anymore. It's only going to fire once. It's in the global scope. But I can click on this button. How many tacos did Christian eat? Let's find out. Boom, our next breakpoint was hit. So over here, if we look, we can see that it tells you the scope is local inside of this function, right? It doesn't tell you what the function is. As a matter of fact, you can see it says anonymous right here because this is an anonymous function. It doesn't have a name. If this was a named function, it would tell you the name. We can see the taco count. It's undefined, but it's equal to I times 2. Oh, I is still 3 because of our fun little var problem. Interesting, right? So if I go ahead and hit F11, it gives us 6. Classmate's still Tamer. Oh, there you go. We can see the bug manifest itself. All right, okay. And then we can get these messages about Tamer. I clicked the button about Christian, though. Well, we've just gone over all of these issues with scoping and var, right? var is doing some wacky things, and this is kind of our test. So how do we fix that? Well, we should probably look into using our let and our const, right? So classmates, classmates, what should it be, let or const? Const, why? Because we never changed the classmates array. That's correct. What about wrapper? Also a const. Why not a let? We're appending a child to it. Exactly. We're not actually changing the wrapper itself. We're just changing information like about it, stuff that it holds, right? We're not actually changing what wrapper this is, though. So it can be const as well. What about this var I? Can this be a const? It has to be a let because we're reassigning it every time we go through this for loop. Exactly. What about classmate? That can be const. It's not being reassigned. What about button? Still const. Yes, exactly. Nice. What about taco count? I heard let and const. Why should it be const?
Because it's not really changing value.
Yeah, because you're only assigning it once. Even though you're doing math here, this value is calculated before it's assigned to taco count. But taco count's never changed again, right? So this can be a const. So you can use calculations to set a const. You just can't, I can't run taco count plus equals 2 or taco count times equals 2, right? Again. I can't do it again because it's already been assigned. So now we're going to alert. And this should be dramatically different. So I'm going to go ahead and change the code. I'm going to refresh the page. Hey, look at that. Christian ate 0 tacos. Ooh. CJ ate 2 tacos. Ah, okay, we're getting there. And Tamer, he ate 4 tacos now. Oh man, he's still pretty hungry though. Good for him. So you can see we kind of got more of what we expected, right? These values, they ended up the way we wanted them to be. We had the proper classmate per button, and we're good. Any questions on this example? Any questions on that debugger? I know it was a quick example, but you should learn how to use it. It's extraordinarily powerful, and I'll tell you, being good with debuggers will make a lot. It'll make your career a lot easier. Make you far more valuable.
As a
Yeah.
handicapped Mac user, I was able to get it to go.
Good. Exactly. That's what I like to hear. Yeah, Andy?
I just noticed, oh, I don't know if that was weird. When I first clicked the button, it didn't show up, talk about hungry. I couldn't go back to it,
Oh, did you have your breakpoint on still?
I guess.
Yeah, if you still have your breakpoint on, it'll catch, right? And it'll be a problem. So you have to either uncheck them or hit F8 to continue. If you hit F5, it'll refresh the page. So don't do that. Any questions on let and const? How are people feeling about those now? Let's do fist to 5. Much better, much better. I got about half the class participation, so I'm going to say that that was a 5 from everyone. Great. Alright, so what else does ES6 have that's exciting and fun for us? Well, I can already tell you one other thing about this example that really sucks, and that is we're doing a lot of string concatenation, right? So we're doing a lot of whatever plus some string plus whatever plus some string plus doing all kinds of crazy stuff. It's a real pain. And no one likes doing that. It's error prone. It's hard to do. You know, there's just causes issues. So there's a better way to do it. And I've shown my class this. I think I've shown Tuesday, Thursday 2 kind of in passing, but I've not gone in depth. And that is template literals, also called string interpolation. And what it does is it allows you to pretty much embed values directly into a string. So we can convert this into that form pretty simply. So right here, every time we have a string, we can make a slight difference. So if I go ahead and copy this line, I'm going to make it button.innerHTML equals, instead of using quotes, I'm actually going to use backticks. Backticks are right above your tab. They share the same keys, the tilde. You don't hit shift or anything, you just click it. These are backticks. Backticks tell JavaScript that you're going to use template literals, so it's a special kind of string. So for the most part, it's the same. How many tacos did classmate eat? But the big difference is, instead of doing the plus plus and like breaking it up, I can actually use a $ and curly braces, and inside of that I can put whatever I want. So I can go ahead and put classmate in there, and I effectively have the same thing. It's just a little easier to read, a little easier to get, right? You can kind of mentally substitute what this is going to be right in the string. You don't have to write all the pluses, you won't forget quotes, those kinds of crazy things, right? Spaces are exactly how they should be, so you're less likely to mess that up, because that's an easy one to mess up for sure. So let's do this alert. This alert is going to be with our backticks, $, curly braces, classmate, 8, $, curly braces. Now here's another cool thing. We don't have to worry about converting anything, just like with a regular string. It'll automatically take care of that for us, so we don't have to like convert the number into a string or anything like that. It'll just be injected into the template literal as a string. So this is the same thing right here with these backticks and $ curly braces. Easy peasy, right? Way, way easier than the last one. Now, the other thing is when you're doing literal, like we're doing actual strings like this with the quotes and everything, if you have a new line, you have to do the escaped \n, right, to say this is a new line. Well, with template literals, we kind of have a few different ways we can go about doing this that are pretty powerful. And I'll show you the way I like to do it, and I'll show you the way other people like to do it. But alert, and I'm actually going to open up the function like this, the parentheses, and I'm going to start my backticks right here, all the way to the left of the screen. And I can write, that's a lot of tacos. Classmate Then when I want a new line, I can actually type a new line. Now notice I'm still in the same set of backticks. Taco about hungry. Excuse me. So I'm in the same set of backticks right here. It is not liking something about my backtick. What are you saying? Oh, this is a linter. Don't worry about that. It's fine. That's just my linter telling me I'm dumb. But it's okay. You don't have to left align it like that. You could do that, and that's fine. But the thing is, the new line has to be in there. And the other thing, this is a literal. So because this is a new line, I actually do have to left align that, or I'm going to have all that weird space as well. So these are ways that you could do it. I could just do that. But then, if I needed that to be literal, to have a new line as well. So, your new line's an actual new line with these backticks, which is kind of nice. So, that's been changed. We can go and reload the page. We'll see our template literals, and we can run it all. Oh, I have the 2 alerts in there now, too, so they're both going to go. And they look exactly the same, functionally equivalent, right? It's just a little easier to manage, I think. And that's really all there is to template literals. Do not use quotes, use your backticks, and you can actually inject quotes on in there, right? Which is another nice thing. So if you wanted to put these quotes around this guy, as long as you do it around the $, you can. So if you want to say, that's a lot of talk, Taco's Christian, you know, you can, and add that emphasis. That's also nice. It makes your strings look cleaner. Any questions on these template literals? Cool. Well, our next activity, activity 105, you're going to be converting the file to use template literals. So go ahead and work with a partner and do that. Spend a few minutes working on that, and we'll go over it together. You're also going to be using some string methods in this one as well. Let me just send you some stuff. So I'm sending you the MDN article, Mozilla Development Network, on strings. If you want to find a string method, you look on this page and you go ahead and look at the methods, and you can actually click them. They're on the left-hand side and see what they do, right? So pad end. Oh, what does pad end do? Oh, okay, well, you can actually pad the end of the string with a character. Wow, that's pretty crazy. So it shows you examples of how they use and all the things you can do with a string. So this is going to be a very, very, very valuable resource for you moving forward in your career. So I slacked that out. You can go ahead and use it for this next activity if you're trying to discover the kind of methods you can call in strings. I'm not going to help you much on it. You should learn how to read it yourself because you're going to need to in your job.
already got that. It's very specific. For now I know how you know what you're doing. Yeah. That's how story works. Also, not myself. So, originally a functional example of string interpolation. Now it's another. Watch this. Dollar sign illustrates the insert value of its also honestly plus one.
Nobody will.
Check out this board. And also salted zooms, yeah. So what I learned up here is that for each, this represents very specific. So it's very useful. Half of them shorter. Right. Maybe they do making sure it's closed and everything. You write it in one single line.
What number one of content?
106.
All right, let's look at this example. Okay, so all we really wanted you to do on this one, well, there's a couple of things. The main thing is we wanted you to use template literals instead of the string concatenation, because string concatenation is pretty ugly, and especially in this case where we have a lot going on, it's extra ugly. The other thing we wanted you to try to do was use better string methods instead of index of, because you could do index of for pretty much everything to see if like a string has something in it, but you don't need to. There are better methods, and if you look at MDN, you can find some better methods and stuff like that. So, for instance, if we want to rewrite with template literals, well, here you go. We can go ahead and do it that way. Remember, we just use the backticks, and then we use the $ curly braces to show that we have a literal. Oop. I'm going to open these side by side so you can see the difference. No. Oh, man. Alright. So right here, this is all the same, but right here on line 16, we start getting to our literals, right? So you can see we have the backticks, we have the $ curly braces to kind of inject the stuff in, and everything is well and good. Now for our methods, or string methods we could use that are better, why don't we compare them? So look, this is the code you were given. We have an index of house Targaryen equals 0. So, is the first thing in this string house Targaryen? If so, we can move defender. You could also use string.starts with. Effectively the same, functionally equivalent, a little easier for you to type, right? And makes a little bit more sense because it returns a true or false as opposed to a 0 or the index in the string that it starts. So the next one is basically just, is the index greater than or equal to 0? So does it exist at all? Does infringed on Lannister's honors exist at all in the string? Or you could just use includes. Does it exist at all? That returns a Boolean. Is it anywhere in that string? If it is, then great. Go ahead and move the defender. Same with the infringed on Stark's honor. If the text at all includes infringed on Stark's honor, then we can go ahead and move attacker. Whereas before, we'd have to do is the index greater or equal than 0, and we might even have to do more than that depending on how complex it gets. And then again, everywhere else we have text, we can replace it with the backticks, $ curly braces, and just kind of inject what we want into that string. Makes it a lot easier. Are there any questions on these template literals? Any questions on these string methods or how to find them? Any questions at all? Fist of 5 on the template literals. Yeah, it's not a particularly difficult concept. It's just a nicety that we get. So, you have a question, Andy?
Not a question, it's more of a problem. I don't know. I've been holding it back because it really kind of stupid and easy, but I think
No stupid problems.
$sign, like none of this was fine in that code.
Um,
Last activity and this activity, it's just staying like orange, which is like the default.
Okay, do you have the backticks or are you using like a single quote? Does one of the TAs want to check out his code? And see what could be going wrong there? They'll help you out. We're going to go ahead and move on to the next activity, but we'll get it taken care of. Yeah, question?
Line 51 and how you get down.
Line 51 in the solution? Ah, yes. So line 51 in yours had the /n loser whatever /n houses left with a bunch of /n's. You can actually just open up the backticks. Oops, my bad. You can open up the backticks right here, and then when you enter a new line, it's a literal new line, right? Like literally it is a new line. So you just hit enter and enter a new line, and that's how you get that. Next line, it's also on a new line. Go ahead and hit enter, and that's how you get there. Next line, you do the 3 dashes, new line, and then you just enter a new line after that, and you have a new line. So literally, when you want a new line with the template literal, you literally enter a new line. We'll slack out the solution too, so you can look at it more kind of in depth if you'd like to. So that's the nice thing about template literals. They're literal strings. Literally, you know. Any other questions on this code? Cool. If the TAs could slack out that solution, that would be fantastic. Okay, what are we moving on to next? So it's only 11:15, so I'm not going to break yet. I'm going to do a few more exercises before we break. We'll see where we are in the class. Strings that have new methods, arrays also have new methods. Whoops, don't look at that. So what I want you to do is go ahead and go through the code in 106. And you want to try to research new array methods. I just spent a few minutes trying to figure out if there's new array methods added in ES6, and I'll send you the MDM link for arrays that can accomplish all of this code without the for loops. So we have an array exactly that we're using, like very specifically, and we can do all of this stuff with for loops, and there's a whole bunch of work here, but is there a way to do it a little bit more elegantly in ES6? The answer is yes, but what can we do? So let me get the MDN link for you that will have all of the array methods you can use Remember, just look on the left under the methods, and just try to find some. There might even be some in the main array page. So again, spend some moments, work with partners, kind of go through this MDM documentation and find better ways to compute these functions or compute these for loops, right? That's our next activity.
Example has bar for the setting the array, but const for setting the results.
Don't ask.
What bar?
Oversight, probably. It might be open source. You might be able to go submit a pull request. I don't know though.
So that the mean, the here, one and that, so we are only
Not that you take the data and then run some sort of modification to each of the classes that have to be created.
Okay, let's go ahead and go over this one. So there's a lot of cool things you can do with arrays in the latest version of JavaScript. A lot of cool functions that you'll see actually used quite a bit in JavaScript too. For some reason, for loops are overrated these days. So people are like, yeah, let's not use those. Let's use everything else that's cool instead of for loops. One thing to note about like for loops and stuff is, yeah, there are functions that can functionally replace a lot of loops, but it's very, very important that you understand them at a fundamental level because they're ubiquitous amongst every programming language, and understanding how they work is really important for understanding a lot of things, scoping, you know, basic iterations and conditions and stuff like that, right? So there's a lot to them, and they're used all over the place. But once you have that understanding, there are nice helper functions that can get around the boilerplate of a for loop. And sometimes they're worth using, sometimes they're not. So why don't we go ahead and go through them? Well, if you were scouring the MDN, you probably found a lot of these. And for each is kind of the keyword here, right? So you can replace it with a for each. Oh, well, they gave you the function names to look at, I guess. Oh, jeez. They didn't make you do any work. You had to figure out how they work, though. So anyway, this one just iterates over a loop. That's all it does, and it prints out information. If you just want to iterate over a loop, you can pretty easily do that with the array.forEach. And it takes in a function, and the variable at that function will be the element at whatever index it's currently at. So it'll start at index 0, then index 1, 2, 3, so on and so forth, and you'll get each princess, right? So you'll end up printing 4 princesses here. And it's just simple console log. Nothing happens. You're not changing the array, so it prevents you from changing the array in the loop, which is very valuable. So in that sense, they're very valuable. But you can't like break from the array or anything like that early, so there are problems there. But anyway, this is just a simple loop over every element in the array, so I can do something. I can do something with that element, but not necessarily with the array, right? Any questions on the for each? So now we start getting into a little bit more of the functional-esque. In functional programming, these kinds of functions are used a lot. The functional-esque things you can do with arrays. So for instance, we have an array of names, and we want to take the princesses and just get the name out, and then print the array of names. Well, there's a function called map. And what map is intended to do is transform an array element by element. So you have an array of something, and you want to transform each element in the same exact way. You absolutely can, and what it's going to do is build that transformation with this function that you inject, and return a new array of the transformed elements, right? So what do I mean? Well, with map, you'll give it a function, and again, your input value will be the element in the array for whatever index it's at that time, right? So in this case, we have 4 princesses. It's going to execute this code 4 times, and you're going to get each princess individually. And then you need to transform it. So you need to return a new value from this function that's going to represent that princess or that index in the array in a different form, right? So for instance, we have our princesses and we just want to have an array of all their names. Easy. Just return the princesses.name, and at the end of this map, you're going to get a new array with the same number of elements that has just the names in it. So it's a transformation function. And the advantage to using a map is you're not doing anything to the original array. The original array stays intact. It's not changed at all. You're creating an entirely new array, which is what you want. Unless specifically you're going to be destroying the old one. There might be a case where you wouldn't want to use the map, but honestly, maps are very powerful for this reason. You're not affecting the original array at all, and you can run a simple transformation over every element in the array in the same exact way. Any questions on the map?
Yeah, so you can use that new array and do different things to it, but at what point does it ever...
It's never the same old array.
Right, but it always exists in memory.
Yeah, it'll exist as the new array until you're done using it. Yeah? So the next one we have is a filter. Well, imagine we're looping through an array, and we have some condition in which we don't want to include new elements in the new array, right? So we want to construct an array of some of the elements, but only in certain scenarios. Well, there's a nice function for that called filter. And this takes a function. You'll be able to parse through each element in the array one by one, and it returns a Boolean, true or false. If it returns true, it is going to include the element in the new array. If it returns false, the new element, that index in the array will be excluded. So in this case, only names that start with M will be included in the new array. So we only have, we have two, Mulan and Moana, right? So we're going to end up with a new array of names with only two elements, Mulan and Moana. The other two are just ignored. They're excluded from the new array altogether. Again, like map, this M names, totally different array with totally different elements. And this names array is unchanged. So you don't have to worry about affecting the names array. You can still keep it, but you might have a function that requires only the princesses with names that start with an M, right? And so you might want that to be able to pass it to the function, and here you go. That's how you could do it. Questions on the filter? Now we're getting into the fun stuff. We're getting into a reduce function. So why is it called a reduce? Because you're effectively reducing an array or some collection into one or some reduced form, right? So in this case, we have a sum. So what we want to do is find the sum of the princesses' ages, right? Well, in the traditional for loop, we set a sum variable, we loop through each princess, we get the age, we do a plus equals, and then we can go ahead and if we want to, we can get an average of that or whatever, right? So in this case, we want to run a reduce function that will just give us our sum at the end. And what we have is a slightly different function in this reduce from the other one. So before we just got the element, each element at each index, right? And that's all we got. With the reduce, you have two parameters. You have the first one called the accumulator, and the second one is the element in the array you're currently at, right? So index 0, 1, 2, 3, this is going to be the element. This is the accumulator. Sometimes you'll even see it abbreviated ACC, which makes it a little confusing. But the accumulator accumulates your reduced value. And what you have to do with the reduce function is return the new value of the accumulator. Okay? So you're going to get this accumulator. You're also going to give it a default value right here. So the reduce takes in two parameters as well. It takes in this function is the first parameter, whereas map, filter, for each they only took a function in. But it also takes the default accumulator value. So this is what that accumulator is going to start as the first pass of this function, right? So you're just going to go ahead and you'll start with 0 and I think Mulan, Rapunzel. So we start running this. We have 0 is the sum and Rapunzel. We're going to get Rapunzel's age, which is 18. So we're going to have 0 plus 18, and we're returning 18. The next function is going to be sum of 18 plus Mulan. We'll get Mulan's age, say she's 16. Now we'll have 18 plus 16, we have 34. We'll go to the next function. We're going to have 34 as the sum. We'll pass in the next princess, who is Anna. She's 18 as well. So we'll have 34 as the sum plus 18. What is that, 52? We'll return 52. We go into the last one. We'll have 52 and Moana, and she is 16 again. So now we'll have 52 plus 16, we have 68. Your final sum will be 68. We'll divide it by the princess's length with 4, and then we'll get the average, 68 divided by 4, whatever that is. That's the reduce. It is probably one of the more powerful ones. I mean, there's a lot you can do with the reduce. For instance, say you only want to return certain princesses, right? So if the name starts with an M, you don't want to add them to the sum. You can just return the accumulator as it is without changing the value. As long as you return some value that could stand for your accumulator, it's okay. So, excuse me. If princess.name.starts with M, right? It's gonna be capital. Then you can go ahead and return sum. Nope, that's not it. I can't type today. Why is that giving me an error? Uh,
Yeah, yeah, that's closing bracket.
do I?
Not extra closing parentheses. After the F.
No, that's for the if.
Yeah.
Why is it returning? Search string. I gave it an M. Oh, strings. That's ESLint. God damn, ESLint. All right. Throwing you through a loop, right? So anyway, you could do something like this, right? So now the sum doesn't change with these princesses, so it affects the overall accumulator value that's coming in. But you can like do conditions and stuff to determine how you want your accumulator to change. So it's extremely powerful, right? This reduce one's a little bit harder to understand. There's a lot moving here, but does anyone have any questions on the reduce? Cool, so let's move to the bonus. The average of the age of the princesses whose name includes an L. So there's a couple ways. We could do it pretty much the way I just showed you, right? Where we don't change the accumulator when the princess name has an L, or you could filter the princesses' names by L to begin with, and then only do a reduce over the L names array. So the way I would probably write it, just to, I mean, both ways are valid, but the way I would probably write it would be something like this: return sum, right? Because then you're just not changing the accumulator at all, or you do want the names. So you could be, if it does not include L, then just don't add anything to the accumulator, right? If it does, then go ahead and add the age. So there's a bunch of ways you can do this, but filtering first and then running the reduce, or filtering in the reduce, or something along those lines is totally fine. Any questions on these array functions? Right here? That's the default accumulator value. So the first pass of this function, sum's going to equal this. 0. Yeah, question?
Can we go back to the map function?
Sure.
It's just mine returning the amount of time.
Okay. We'll have one of the TAs look at it. You might have a typo. Or, yeah. Might have a typo or something. Any other questions on this and how they work? High level, like what's going on with these functions? They're pretty powerful functions. Obviously, as you guys can all see, they can take away a lot of this boilerplate work. So sometimes they're really, really nice to use. Map and reduce, I use a lot more than the other, than for each and filter for sure. But they're all very valuable. I would say the least valuable one is for each, surprisingly. All right, let's go ahead and move on. We're going to do these next activities, and then we're going to go ahead and take a break. So, let me go to number 7. Whoopsie. Okay. So now we're going to talk about arrow functions. And what they can do for us. So, we have, so far been using the function keyword. And the function keyword's great, but it's kind of verbose, right? You have to type function everywhere, and, you know, does it really mean that much to you, especially when it's an anonymous function? And the answer is no. If you didn't have to type it and you could save characters, great. So they have this new syntax called arrow functions, where instead of putting the function keyword before the function declaration, you just use this equals less than, which stands for goes to, or into. So it could be A and B goes to this function, right? And it's effectively functionally equivalent. Now, there's a slight difference that we'll go into in a moment. But some notes about these is if you have a regular function keyword and you try to use the goes to, it'll fail. If you have the no function keyword and you forget the goes to, it'll fail. The goes to is the secret sauce here for these arrow functions to say, hey, this is now an arrow function and not a normal function anymore. Right? So they work functionally the same. Now the arrow function, we can make it even more concise. So you can do inline function expressions. So you don't have to, on single line functions, use the curly braces anymore even. With this one, you always have to use the curly braces with the function keyword. But with the arrow function, you can just leave them out. And this is effectively the same thing as multiply 2. If your return statement is the first line, you just do this. And it's like, it just equals that value. It goes to that value. Right? If it's a single line only that has a return value. If it doesn't have a return value, then, I mean, you can still do it, but it's weird because it's implying that there's a return. So right here, again, single line value, it's just going to return x times x. No need for the curly braces. But there's no arrow function. You can't be that nice. It's not that nice, right? You have to have the curly braces. You have to have that function keyword. And all that fun jazz. Now, here's another thing. This doesn't work. That doesn't work. If you're going to have a named function like this, note that there's no arrow function equivalent. You absolutely must make it a regular function. Absolutely. The only time you can use an arrow function is if you set it as some variable. Yeah, it's my linter. Saying I shouldn't have all that space there. I don't know why my linter magically started running on some of these. Probably because they're ES6. So that's just, it's like a more terse way to write a lot of your functions. So you can imagine, you know, sometimes event handlers. Now I'm going to show you the caveats here, but sometimes event handlers, so say you had like a button.on. Yeah, it's just picking random stuff. Say you have a button click, and the button click just needs to do like an alert. Right? My linter's freaking out, but this works just fine, and it's a little bit more terse. So for your anonymous functions, which you should try to use as many as possible, there's no reason for you to use the function keyword at all. Right? Do you have a question, Jesse, or just stretching? Any questions on this right here, this more terse kind of syntax? I'm going to show you what makes this a little bit more challenging than it seems. So we all remember with these functions, we had this fancy this. Well, arrow functions don't have this, which is a good and a bad thing. It's a good thing mostly because then you can't abuse this and there's no weird rules to learn. But it's a bad thing because if you know all about this and you like to use it, well, you can't anymore. And it also is a bad thing because certain functions require this. So some jQuery stuff might have $ this. That doesn't work anymore. So you'll get a bunch of errors and be like, hey, jQuery on-click handler not working. Well, if you need to use this, too bad. So right here, we have a function, a named function person, and we're actually using this.age, right? So this is like a constructor, effectively. But we have the set interval in here, and it has an arrow. And in the arrow, we're using this.age++. And this works, surprisingly. Now, before, if we had a set interval, and we did function like this, and we did this.age++, we would end up with some weird error. Because this, it'll be like, this.age is not defined. And to get age in there, we'd have to do something like const self equals this, right? And then we could do self, because we need to be able to pass this reference into here and skip this function's this definition altogether. But with the arrow function, it doesn't have a concept of this. So when you use this in an arrow function, it just absorbs whatever the parent's this is. So in this case, the parent function is person, so this refers to person's this. A lot of this is going on here, but this is how this works with an arrow function. It does not have its own. So that means if you have const myfunc, what happens? Could be an error, could be the window, could be global scope. No one knows, so don't do it. It's pure magic. I don't know. You'd have to console log it and see. I'm pretty sure it'll go to the window. But it could go to undefined if they make arrow functions work that way. I honestly, I don't do this. I haven't done it in a long time, so I can't even tell you. We can go ahead and run it in Chrome and find out right now. We'll just go ahead and open the DevTools, and let's open up our console. I'll just define it. Oh, I'm not doing it on your screen. My bad. Should do that. Let me pull this down. Alright, so right here, I'm defining this function. This dot name equals Carson. So there you go. It attaches it to the window, whatever this global scope is. So if you do it on a window, it's going to attach it to the window. If you have just an anonymous function that tries to use this, an arrow function tries to use this, right? Where if we had and we called fn2, or let's set this dot name equals undefined, right? So now if I call function 2, and I'll try to, dang, I can't scroll this up. Let me, now if we call function 2, oh, well, it must have automatically attached to the parents this too, in that one. Anyway, with an arrow function, it's just wild. Don't try to do it. But if I tried to make this a constructor, so if it did like so, I can do that. However, if I tried to do like that, X is undefined. It's not an object. Oh, I'm sorry. I need a new. It actually throws an error altogether. Can't even use arrow functions as constructors either. Oh. It still throws an error. Because you can't use arrow functions as constructors. So there's a lot of things you can't do with arrow functions. They're a lot more strict. They're defined as explicit functions. They have no this context. So you can see right here, this one works great because there's no this in this arrow function. This one right here, we have to store it in another variable, right? If we want to actually be able to use it. And this one, again, you can bind this, and I'm not sure that you, yeah, you can bind this function to the parents this, and it'll work fine like the arrow function. But it's a lot more work to call .bind and all that stuff and figure out what to bind it to. So the important thing, the most important thing with the arrow functions is that this idea of this changes significantly, and it doesn't have one. So you need to use, you need to be careful if you're using an arrow function in understanding what this actually is going to be. Just like in a regular function, you have no idea sometimes what this is going to be. So best bet, don't use this. Any questions on these arrow functions? We're about to go to an exercise where you'll have to use them, so you'll get some experience with them. Cool. We're going to do activity 108, and that is the student underscore array arrow arrays. So you're going to convert that last activity with the array functions to use arrow functions instead. Guess you're done, huh? Did you do it with the single line arrow functions, or did you do curly braces?
I did curly braces.
So I guess you can make it a little bit fewer lines of code. Right?
If you're gonna console log something, then you can use the curly braces.
You don't need them. I prefer them. I'll show
You
you.
can just do arrow console.log, really?
Well, the implicit return value in JavaScript is undefined, and console log returns undefined, so it works. But should you? It's preference. It's preference for me. I have a reason. Whether it's good or bad can be debated, but I have a reason.
Okay, well, considering you have years on me, I will trust you.
Yeah, well, lots of other people with years might not agree. Some might.
I don't like those other people with years.
You know what? I appreciate that.
Don't forget, I haven't forgot about the donut.
Okay, good. I was just about to say, 2 weeks, man. I'm looking forward to it. I've gone this whole week since last Saturday without any added sugar. I made it. Tomorrow we're going to get brunch. I'm getting pancakes and just smothering them with syrup. Celebrate my week of no sugar, and then I'm going to do it again.
It's a little easier for me because I don't have a sweet tooth for food.
Yeah, I do.
I'm like a sugary beverage person.
I definitely like that Cokes, and I love my soda, man. But I just can't do it.
I've been having like 1 or 2 sodas a week lately.
Yeah.
I'm like, I need to stop.
My health I can't take it. I've just got too many things that could affect me. And, you know, we're busy all the time, so it's hard to go to the gym and all that.
Oh, definitely. I noticed that when I don't drink soda, I'm less more than
Alright, let's go over this example. So we can replace almost all of these functions with a single line arrow function. So you can look and just see it's just so much cleaner because there's just not all the noise of the curly braces. Look at this map. Like this is nice, right? Like almost no code there. If you want to be really lame, you can just like make it even shorter, right? I mean, for this kind of thing, it's actually not a huge deal. You're literally just taking it and you're transforming it to a dot name. So this is the one case where, yeah, should you name your variables nice, but if you didn't in code review, I probably wouldn't say anything. I'd be like, that's cool, man. So, you know, but it's so much more terse, right? And that's what's nice about it. There's a disadvantage in that if you go overboard and what's happening in these single line arrows is too complicated, it's hard to understand. And I know lots of people who think that because you can make it terse, you should make it terse, and that is not true. Remember, the most important thing is that your code is readable to other people and to yourself later. Terseness and elegance come last, right? And sometimes a more verbose solution isn't as elegant, not as pretty, and you're like, I want it to be pretty, but you need to fight that inner engineer, right? And tell them to shut up and just do it the better way and the easier to maintain way. Now, the only thing I disagree with here, and it's an aside and it's just a minor gripe of mine, is when you're not returning something from an arrow function, I do not feel that you should have it in a single line. So console log returns undefined, so we're not returning anything actually, right? Even though technically every function does return at least undefined in JavaScript, what I'm telling readers of this code is that they should not expect a return value of this function, right? And so just from reading it, I have a little bit more context into how it's supposed to be used. Now, granted, for a for each, it's not a huge deal because we know that the for each isn't returning anything. But if I just had a function that was supposed to console log, like a log function, I shouldn't expect that to return anything. And if I have a single line anonymous function, you know, sometimes you may think that it should because that's what that implies, right? So it's just kind of a gripe of mine. And sometimes with strict linters, they won't even allow that anyway because they have an opinion towards the same thing. And you can set that rule. So that's just kind of like my 2 cents on what my experience has told me. From reading it, it seems a little easier because then you can deduce, hey, this should not return anything. I should not expect that, right? And it's just another context cue for the reader. Other than that, though, it's pretty straightforward. You get rid of the function keyword. You add this goes to, little equals less than or whatever. Get rid of the curly braces and you're off to the races. You've got yourself an anonymous function. Any questions on this rewrite example? Any questions on anonymous function, arrow functions and how they work, or anything we've gone over yet today? I know we've gone over an absolute ton of content, and I'm sorry that it's so much at once, but you know, I didn't make the curriculum, so I empathize with you. Any questions? Cool. Let's come back to class at 12:45, and we'll finish up. We have quite a few more things to look at, so I'm gonna stop the stream for now, and we'll resume at 12:45.